My name is Roland Reyer. I'm a so-called, what we call at Autodesk, a technical specialist. I'm the Maya guy, so to say. I'm based in Germany, close to Düsseldorf. And today I would like to talk about the new features and improvements of Maya 2020. We already have Maya 2020.2, an update that fixes some bugs and comes with some minor improvements, which is the new policy at Autodesk with releases. When we release a new version like Maya 2020, during the year you will receive updates to this version like bug fixes and also additional features that will not break your pipeline. So you shouldn't be afraid to install these updates. They, in general, they fix things, they make things better, and sometimes even add some functionality that you didn't receive in the initial 2020 release. So here's a picture of myself because there's no webcam on. That was me 10 years or more than 10 years ago. I'm a little bit grayer up to now, so just so that you know who's talking here. What's new in Maya 2020? I've segmented this whole thing into the overall themes or topics in such a software. We will go through and talk about some specifics of these things, like in modeling, for example, or in rigging. There are things that I would like to show you live in Maya. I've also recorded some videos here, so just in case the performance will be very slow, I might go to the video and just switches from there and explain what I want to explain here. So in general, in Maya 2020, there was quite some improvements. Things like Arnold, the new GPU rendering in Arnold specifically, are a separate thing. So we're not going to dive too deep into Arnold, the renderer. I just want to mention it and just want to, show you there's more in Arnold. You can, that's a complete software by itself. So we're not going to talk too much about that here. Just shortly about the GPU rendering, I have a short demo recorded here using an external GPU just to show you the performance gain that you can have when you use such a GPU rendering machine. Also, Bifrost is too big of a topic that we can handle it in this time here. So I will go a little bit over Bifrost and more generally explain what it is. It's not just, clouds and dynamics. It's much more than that. It's more like a programming language inside Maya. And there are more things here. So when you see so much text on a slide here, don't read it. I encourage you not to read it. Just, see there's a lot of things going on. These little animations here are much more important than all the text on my slides. So you rather look at these little animations to see, hey, there's something going on in the outliner, for example, or in the timeline. As you can see here in the timeline, you now have the ability to scale the timeline directly. You just grab the edge and pull it up. And then in the timeline, you can have an audio signal that is synced to your animation then. So that's the overall message here. Arnold 6, as I said, we're not going to show all of the improvements in Arnold 6. Just the one thing, the most important thing is the GPU rendering. We will go over that. Here you see a long list. I simply couldn't make up my mind what to show you and what to tell you about. So I simply did a copy and paste with all the text. Again, please don't read it. There's a lot going on in Arnold 6. One of the big important improvements is, of course, the ability to load USD procedurals into your scene. So in Maya, for instance, you can load a complete USD universal scene description file and see the contents. So you can turn it into a bounding box or really look into the file and see the contents. And then and you can see it in this image here, you can even dive into it, access single objects or groups of objects, assign shaders, move them around and stuff like that. So there are modifiers there where you can add parameters to modify these objects. And that's a pretty cool thing already. So that brings USD already in your production pipeline so that you can use it. There's an open source page on GitHub. Autodesk Arnold-USD will give you more information about this. And there's already YouTube videos about how you do that. Also on the Autodesk area website, there's a blog post about USD where you can see how to do this, how to load a procedural into Maya and to render it in Arnold. So this specific example here is super cool and very fast. GPU rendering, I tried GPU rendering since it was in beta version in Arnold, I don't know, 4 already. And it's super impressive. So with the CPU, this example here on my laptop, or actually on the older laptop, the one that I had before my current one, was about 14 minutes to render this image in the high quality that it's, standard, that is set by standard. And in the GPU, you are much faster, 5.5 minutes. So that is a huge improvement, especially for look dev artists who need to render all the time to see what they are setting for the lights and the shaders. So that is super fast. And these 5 minutes here, I mean the GPU in my laptop, which was a Quadro card, a Quadro 4000, I think, that was 5 minutes 30 compared to 13 minutes 50, so almost 14 minutes, which is pretty good. And now I have an external GPU, like this one here, the RTX 6000, that is in an external housing beside my laptop, is connected with USB-C. And that thing renders like hell. So I have a little video here that is that I can play. So here's an example of compared rendering times. So that's my new laptop with software rendering. You see, it starts in the middle here and starts to refine what you see, and it gets less and less noisier. So in the first pass, it's quite grainy, and second and third passes become much better. You can turn on IPR and then rotate the camera, and it keeps rendering. And that's the cool thing, especially in look dev, that you can modify your scene. You can shift objects around, move lights and stuff like that, and you see live what the rendered image would be like. And it depends on the scene size, of course, and the type of shaders that you have, but of course heavily on the CPU that you have. How fast you can see things here. So now I'm going to open the settings, the render settings, and I switch to GPU rendering. And in the list below, you can already see that the Quadro RTX 6000 is registered. And when I turn on IPR, you can instantly see that, this refinement of a better, less grainier version is much, much faster. So with this GPU, I would, instead of rendering 5.5 minutes, it would be like 1 minute or 2 minutes to get a super smooth, high quality image out of that. And these performance improvements, of course, you pay a lot for these cards, but it's still much cheaper than your work time when you sit there and wait for a renderer to finish to, find out what kind of anti-alias you have to set and stuff like that. So this is a super cool improvement in Arnold 6. And then, of course, there's other things that have been improved. The team is all the time working on things like the light editor and the render setup to improve stuff like that. There's a new standard surface shader that you can try out and play around with. Of course, the interactive display is always worked on so that you can interactively see more of the materials and the light situation in your scene without having to render the whole thing. Okay, next topic is Bifrost. As I said, Bifrost is a huge topic. It would take too long to just give a short example for all the things that you can do in Bifrost. Many people think it's just a dynamics engine. But here in this example, you see this landscape was done with Bifrost. So the ground, the underground was maybe modeled, or you could also be done procedurally, but all the plants, you know, the placements of the plants, that is all Bifrost. And that is a super example of what you can do with Bifrost, and it's also super fast. Here's another one that was done with Bifrost. So set dressing is one of the big topics, has nothing to do with dynamics, but you know, that is one of the things that you can easily do with Bifrost. Here's an example that doesn't even have any modeling things as an input. So all of the stuff is created in Bifrost, even the rocks here. And in the next image, you see an example of what such a Bifrost graph looks like. So it's very much like the node editor. You have a bunch of nodes that you connect together. So on the left side, you usually have some sort of geometry input or object input that gives you, you know, a shape that you want to deform or modify. And you can also input values. So from the attribute editor of the animation system of Maya, you can input values into the system to do that. And then these boxes, these light gray boxes, are compounds, what we call compounds. So you can group these things together to make a node out of it. So a bunch of nodes can be grouped together and collapsed, and then you have a new node, like a function in the programming language. So that's the kind of things that you can import already in Bifrost. You can, of course, also build it yourself. It's not very complicated. It's much easier than the node editor. Most cases, it's just one connection between the two nodes, and the whole geometry flows through such a connection. And then you can do things like a fire here. So real dynamic simulation. These fires actually burn fuel, really. So you can set the amount of fuel that you want to burn, and it does some sort of a simulation here, which is super cool because you can ask somebody in film, you know, how much fuel and what kind of fuel would you use to achieve this effect, and then try to simulate this in Bifrost to achieve a similar thing. Here's a character under a cloth object. This should be looping actually, and you see the complexity makes it necessary to have a super stable solution, right? So when you have so many details in a cloth simulation and so much movement, then of course the danger is that it gets stuck, or you know, you have a lot of intersections and stuff like that. Here's another one that twists a piece of cloth, which is not as easy. So in many solutions, you see this part here intersect and then collapse and stick together. And this is not the case here in Bifrost. Here we have an MPM solver example. You know, some MPM solver examples, you see it has something to do with particles, but also with sticky geometry. So some of the pieces stick together. You need a certain force to destroy this stuff and get it smaller. And then up here we see an explosion. Again, this is with the fuel, a very important aspect of these explosions. It's the amount of fuel and the temperature that you use to burn everything. And down here we have finally a smoke example. So with these examples, we always expect Bifrost to be just dynamics, you know, dynamic simulation of cloth and particles and volumes and so. But the two images before that should have shown you that it's does more in your scene. So here, retopology, that is an example that Bifrost could do. We will talk about retopology in a second. So Bifrost can do that as well, retopologized geometry. And here's an example of a skin cluster that was done in Bifrost, where you can add things like procedural weighting to the skin deformer, so that you can adjust these stand-in objects and then, you know, have geometry snap onto the surface that you are deforming. That would work. A proximity deformer, we will talk about that in a few minutes. Delta Mush is there. You see there are nodes there that do all these kinds of deformations, so you can use it with your own skinning algorithm, which then would be topology independent. Here you see how the surface gets retopologized and still the whole deformation works as intended. Okay, that was Bifrost. Let's move on to modeling. And in modeling, there are at least two very interesting functions that I want to talk about. And these two are the remeshing and retopologizing. And let me open or, bring Maya forward here. And I have to take a look if you can see that and how the performance would be. I have to do it slowly so that you can see it. It's not super smooth here, the performance, but given the fact that this is a full screen presentation, I do totally understand that this won't work. This object here was created using a bunch of Boolean operations. So I took a cylinder and subtracted a smaller cylinder and then put a box in and subtracted that box. And everything is fine so far, but we get some of these weird polygons here. So n-sided polygons that are even concave, there is a number of those here that may cause problems, especially in games. We don't want that kind of stuff. So what I'm going to do here is to select this thing, and then you can use either the pull-down menus to access the function, or shift right mouse button and go here to remesh this function. Remeshing has its own little in-view editor, and here the maximum edge length defines how many triangles you will have. So if you make this edge length smaller, you see that the more and more triangles appear. You can create a super deformable object with that. So you can now bend it and twist it because of this fine interpolation or this fine triangulation. I've undone this change here, so we have the large triangles again. And now I will go and choose another function that is called retopologize. And retopologize tries to make a regular mesh out of that again. So here we have a regular quad mesh out of this object. It tends to smooth the edges here, but that is a function that you can turn off in, here's the retopo, that you can turn off in the settings. So here we have a preserve hard edges function. And now you see, okay, the hard edges are back and everything's fine. We still have too many polygons. So here are two edges in the middle of this flat area. I can remove many of those by lowering the maximum face count or the targeted face count. You see that's much better. Still very irregular here on the side, and I can fix that by lowering the anisotropy. You see that's a much better example. So now we only have quads in the whole thing, and I can even go and select edges, for example, double click here, and then shift right mouse button, delete these edges to improve the whole geometry even further. You don't have to do that. The geometry works right away. So we have a quad geometry made out of this weird Boolean object just by clicking. Another example is, I have to move this one away here just a second. Another example is this one here. This is an object that actually came from the model library that's built into Maya's content browser. So you just open the content browser and you can drop in one of these models. And I use the remeshing here to remesh it super fine. So let's assume this is a scanned model and your manager is telling you, hey, you sit down and you remesh this whole thing and make a nice model out of that so that we can use in production. So then you have a few days of work in front of you, or at least one day. And I just want to show you that you can do it in just a single click. So I retopologize, and this one takes a little bit longer, but I want you to look at the wings after that. This is now the default of 1000 polygons as a goal. So you see here the wings are super clean already. So it detects the orientation of the topology or the orientation of the overall shape. We see these weird normals here on the edges of the wing. I can remove that by increasing the target to 2000. Also takes a moment, but then you will see that this is much less here, this weird normal on the edge of the wings. So we're already there. So you see, this is a super clean topology and with the click of a button. So that would be the first try when I would have to retopologize something. I would first try to use the retopo function to see what kind of results I get. Because from here, I only have a few steps to make to get a super clean and mirrored object that works fine in my production. So let's go back to the presentation. These are the two main features in the modeling currently, the remeshing and the retopo function that we see, that we've just seen. In texturing, so Substance got a big update. When you are used to use Substance, you will see some of the improvements here in this list. There's quite a bunch of new things and improved things, so the whole work should be smoother and you know, much more. There's a lot of batch stuff in here, so batch importing and batch baking to disk is a huge improvement that helps you save time. You don't have to sit there and click on the baking button by hand. Let's go over to rigging, which is a complicated topic. So the whole rigging process involves a lot of deformers, a lot of control objects, as you can see them up here in the upper right image. And these control objects can now be hidden or made invisible by using the Alt-A key. So there is a new hotkey, Alt-A. Very much like in Motion Builder, you can change the visibility of these objects with that key, which helps you, you know, quickly see your model when you are animating, for example, and then redisplay all the control objects, for example, or even the skeleton. So Alt-A 3 times, you click it 3 times, always the same thing, you toggle through these options of visibility. And 2 things that I would like to show you live, or 3 things actually that I would like to show you live, is the proximity wrap deformer that we see in these 2 animated images here. That's proximity wrap. Then we have a proximity pin deformer that you can see here in the list. And then we will later also have a look at the offset parent matrix plug-in that's new in Maya 2020. So let's start here in the list with the proximity pin and proximity wrap. So I'm using this nice character here that I found free on the internet for my presentations. And the first thing I want to do is to proximity pin this cone here to the head. So what I want to do with this cone, so I first have to center the pivot, is to pin it to the geometry of the head. So I pick the head as the target, that's the target surface that I want to pin this cone to. And then here, not under deform, it's in the rigging section under constraint, you use the proximity pin. And then you get this, there's a little locator appeared in this cone, and with the locator I can now or later define the position of this deformed or this pinned cone. So now when I pick one of these faces here and maybe use even the soft selection, and then I move it around, you see that the cone is pinned to the surface. So by orientation and also by position, it's pinned to that surface, which is perfect for rivets on a leather coat, for example, that is moving together with a character or even moved by dynamics. That is a perfect thing to attach a rigid object to the surface. Now, when I pick that little locator here, now I can adjust the position of the cone to the original surface. So when I move it over here, you see that, you know, the orientation of the cone moves around because I'm in a separate position. Okay, so let me undo that whole thing, and I delete this object and the other one, so it's no longer constrained. That was the proximity pin that you find here under constraint. And there's another deformer that's called proximity wrap here under deform. So the proximity wrap is something that also has a similarity in the algorithm. Let me show you an example. Let's say we want to deform this face here using a control object that is more like, that is more like another simplified face. So let's take this one here, this sphere. And in order to see through the sphere, I give it a different material, let's say a Lambert material, and then I turn that transparent so that I can see and select the sphere, but I can see through it. Okay, and then I take this object here, and in the first step, I simply do it so that I say proximity wrap. Nothing happens, so it's not wrapped or it's not deformed by anything else. There's something new here in the attribute editor. You see an edit node button. In this edit node button, I'm sorry, I'm just distracted by the blinking chat button here on the side. So okay, so in this window here, the edit node window now lets you define what are my drivers, so what are my deformer objects, and what is the deformed geometry. So here on the deformed geometry, we already find the head shape because I registered it as such. But I also want to register the driver here, my sphere that I created as a driver. Now this won't work. Look at it when I do it. Add selected. Oh, there's something broken now. Obviously did not work well. I'll undo that, and the reason why it didn't work, I have to freeze transform it first. Not nice, that's not good. I reported this as a bug, it's going to be fixed soon, but now I can add this as a driver. You see here now my sphere is in the list of drivers, and I can now go and pick faces of this object and move them around. You see now it deforms my geometry. It's a little bit harsh at the beginning. Now let me do that drastically. And now we go into the settings here, into the proximity wrap, and increase the smooth influences. Now look at the result. It gets much smoother when I increase these steps here, and the same for smooth normals. 1, 2, 3 steps smooth normals makes it much better. So this is way, way better. Now I see, that's fantastic. That's nice. And usually when you work on something like that and you work for an hour to get the deformation right, you find out, oh my God, I should have included something else. I forgot, for example, the eyebrows. So here we have the eyebrows, and the eyebrows are hidden. Let's unhide them. I should have included them. And normally you would have to undo all your changes, throw them away, and have to redo everything. But not in this case. You can go to the proximity node, to the proximity wrap node, into the edit node window. And here now I can pick the eyebrows and say, hey, I want to add them to be the deformed geometry. Now look at the eyebrows. When I click on add selected, boom, and you see it's now deformed right away. So it inherits all the deformations of my deformer sphere, and I don't have to redo everything again. So this is a new thing. We didn't have that before, that windows are opening here from within the attribute editor. But this helps a lot to make this relationship between deformers and deformed objects a little bit easier. That's the, here under deform, the proximity wrap deformer. And of course, you can also paint weights. That's why it's down here also. So let's go back into the PowerPoint. Oh yeah, there's one more thing that I want to show you, and that is the offset parent matrix. So here in the initial slide, we have this offset parent matrix here, and riggers will probably know what I'm talking about. Let me load an example here. So in this example, we have this workpiece here in the middle, that's the blue sphere, and we have two tools that should grab this workpiece one after another. So the first tool comes into the image and brings the workpiece here, and then the second tool comes in and wants to pick up the workpiece and move it away. So these tools are already animated. So we have the first tool coming in and then deliver the workpiece, and then the second one comes in and picks the workpiece up and moves it away. Okay, we all know this animation task, and it's horrible. So what we normally do is a disaster, and with these matrix connections, it's much easier now. So let's make it easy and make a simple connection. I take the workpiece and parent it to this one here. So parent is under edit. It's an uppercase P, parented. So the first part of the animation works fine. So the workpiece is brought in, and then the second object comes and wants to pick it up. Oh, and picking it up is actually also easy. I say this is a target for a parent constraint of my workpiece. So I simply go parent constraint, say maintain offset. Shall I don't know. Maintain offset. So now the second part of my animation will work. The second tool picks up the workpiece and moves it away, but not the first part. You see, this parent constraint broke my parent relationship with the object, and that's not working. So the whole thing is not working. So let's have a look at the node editor with these objects here. So we have the claw and the workpiece. Let's take these ones here. I can remove all the animation files and all of these here. I don't need to see. I just want to see these ones here. Let's open them all and have a look. So you see there's a lot of connections going on between the workpiece. The workpiece on this one here, there's 1, 2, 3, 4, 5, 6 connections. And here we have 1, 2, 3, 4, 5, 6, 7, 8 connections, and even a connection from the node to itself. So that is a disaster. Way too many objects. So let's delete this parent constraint here altogether. I can close this tab here and then have a look at this object, at these objects here. So we have the parent object bringing it in, and then the second object. And what I want to do now with the second object, actually I want to pick them both and go into the editor and have a look at them. So what we need here is the claw and the workpiece. Let's zoom in here. The claw and the workpiece. And here in the claw you find this matrix channel, and the matrix channel will deliver all of the transformations, rotations, scaling, and shear in one attribute. It's just one connection, and I need to plug it into offset parent matrix, which is not yet here. I have to go through this connection window here, and down here you find offset parent matrix. When I connect it, then it will be displayed. It's there all the time, but it's not displayed, and now it's properly displayed. And the cool thing is now that my animation works. So the parenting brings in the workpiece, and then the second one comes in, picks it up, and moves it away. Oh, cool. So how did we do the second part here? Because this workpiece or this tool comes in without affecting the workpiece. This animation here is done by a group. So this connection, the offset parent matrix, is even so cool that it blends out the movement of any parents of my tool. So only the animation that the tool itself does, which is this one here and this one, only these movements are inherited. The other ones by the parents are not. And it's even cooler, the parenting still works, so I can move it around. the offset parent matrix works. I can move it around, even at the same time where a parent constraint or so would jump all the time, and I still have the channels of my workpiece open for animation and other constraints, so I can still connect something to my workpiece. So this whole thing is a super cool thing. As I said, as a rigger, you will already know what the matrices are about. And by the way, matrices are also much faster to calculate during animation, especially when we talk about complex characters and stuff like that. So these are the two examples here, offset parent matrix and the proximity deformers. The evaluation toolkit is something that not many people open because it looks complicated. We have no idea what it does, and so this is now properly. Initially, it was something that the developers wrote for themselves to find out what's going on inside Maya, how long tasks take, etc., etc. So the developers wrote the tool for themselves, and for themselves, of course, you can imagine it's not very user-friendly because they are developers. They know what they are doing, so they don't need to make it friendly. So now it's user-friendly. It has a proper documentation to tell you what you see here in these profiler examples and how you can improve your scene. So sometimes you see something and you have to identify where is the problem, why is it broken, and how can I fix it. That's the profiler, the profiling documentation. The same for the scene lint window, which was there before but not documented. You basically go in and run an analysis of your scene, and then it tells you, oh, there are flat animations, there is OpenCL stuff that does not run on the GPU. We have animated expressions and stuff like that. And you can fix all of that with a single click. So you can simply jump in and say, fix all of those. It's not a problem. You can do all of these things manually. But with this window here, you don't have to. You can say, hey, I want to fix all these problems. I can even uncheck some of them that I don't want to fix. And then you can improve the performance of your scene and the cleanness of your scene. Again, proper documentation is necessary here. In animation, we see some interesting stuff here. So in these animated windows, you see that the timeline can be now freely scaled. You can just grab it and make it as large as you want. And we have down here, I can show you directly here in Maya. So when we pick these two objects here and go into an animation layout with the graph editor. So here you can now see, hey, I can resize that timeline easily. And when I select pieces of the timeline, let's say, this part of the timeline, that is something that I want to concentrate on. So before the second object picks it up, and I want to create a new bookmark for it. A bookmark is something with a color. So this one here is reddish. And it has a name. Let's call it Roland's bookmark. Okay, so now you see this red line down here, and that is your bookmark that you can pick up. You can mark another time here and Control T to create a new bookmark. This one we're going to make green, and my last name is Ryer. No, English keyboard again. So now we have two bookmarks here, and I can jump to these bookmarks, right? So I can go to the previous bookmark and to the next bookmark, and what it can do, it can show you the timeline just with this bookmark. So when we edit the bookmarks, or there's a bookmark manager down here, you can say, hey, my first bookmark goes from 1 to 84, and I want to, or 85, I want to actually see that. Didn't want that to happen, so I can undo that. So here with this button, you can set your timeline, and here you can say, okay, that's the red bookmark. Let's jump to the green bookmark, boom, and then jump back to the whole timeline that I had before. So I can unframe, so to say, I can unframe the complete timeline and watch my complete animation with this. So that is some of the new things that animators specifically asked for. Also here in the graph editor, we have a lot of new things. Maybe better to explain here on my, so here we have the timeline and the bookmarks and the bookmark manager down here. And in the next slide, there are some new features for the animation for the graph editor. So some of the things, you know, people start to smile when you tell them, oh, we added some color schemes for colorblind people. You know, people say, colorblind people, how can you work in animation when you're colorblind? You would be surprised when you would know how many people have a certain color blindness and how many certain color blindness each individual, me included, have. So there are always colors that we don't see properly or we can't tell apart properly. And these color schemes that you see down here on the left side, the lowest image on the left side, these color schemes are simply there for you to pick one where you can see, where you can tell the colors the best. And that is not for every one of us, it's not the same. Some people have problems with red and green. Some people have problems with green and bluish. So there are color schemes that help you jump over that thing and to work in Maya and work in animation without having to struggle with this color scheme. There's also a light background and stuff like that. Another thing that was added was a display options for the key ticks in the graph, in the curves. So sometimes, you know, the animators complain about key ticks being too big. When you have a lot of keyframes here, you can't see. And sometimes the key ticks are too small. It's too much effort to pick such a keyframe because this dot is too small. And some people even complained about the timeline. So sometimes the timeline is above the graph editor and they want it below the graph editor. So simple stuff like this one here is also worth an improvement. And then finally, you know, it's possible to set the in and out tangent, the default in and out tangent directly from the icon bar in the graph editor. So you don't have to dive into the preferences anymore. That's also has become much easier. Right? So some of these things are not spectacular new functions, but it shows you we care a lot about the users and their, you know, specific needs in their day-to-day work. I mean, a fancy new feature that does everything for you is nice, but in the day-to-day work, if you are annoyed all the time by the, you know, the display of the key ticks, that's of course something that needs to be fixed. So yeah, this is just a video about the time slider and the graph editor. Finally, in animation, you heard about in Maya 2019 the cached playback, the improvement that the cached playback can now help you improve the performance of your workflow. Now it's possible to have animated image planes in the viewport and do a cached playback. There was a problem in the past because an animated image plane can consist of single frames or a video in a certain codec. And that video has to be converted into another video to play it back properly in real time. So that is technically was a challenge to get that right and working with all kinds of possible image planes that you can have. So that has been fixed. And another thing that has been fixed, I can show you, is the playback caching of dynamics. So let's go into, back to Maya Classic. So here I have an example of an animated dynamics object. So it's a simple encloth object here that is that's added. And you see that, you know, there's no playback caching here. I get a warning here. So nucleus evaluation has been disabled because of, right? So there are some things that need to be turned on properly. So the playback speed needs to be play every frame, and the max playback speed needs to be, you know, whatever we can set it to 3, you know, to playback as fast as we can. When I save that, it still doesn't do that properly. So the cache playback, and I see it could be disabled, that I can't see it at all. So I have to show you in my, here in my video. So in the video you see, let's play that back. In the video you see that there is a warning here in the script editor that the cache playback has been disabled, and that's this yellow line here. So, not the missing red line. So what you then do is go to cache preferences and turn on cache dynamics, which is turned off by default, which is a joke, of course. And then you see another red line appear with the playback caching. And then suddenly, you know, the playback caching works. And you can create a new material, or, you know, define a new material, and then on the, and leave the playback where it is and say, okay, just go with the playback. Here, another example, I add a collision object to the dynamics, and then it caches that immediately, and you can scrub back and forth and see where the cached object is. As soon as you move it, look down here, you see the playback cache is recaching, so that you don't even have to do these steps like rewind and play and stop and rewind and play and stop all the time to make this work properly. So this is a nice short example. Watch out for the preferences here down, right mouse button here on the cache playback button, to be able to set in the preference that the cache playback should be turned on for dynamics. So I'm pretty good in time, so the whole presentation will take about an hour. So here we have the last animation example, which is the Rococo Motion Library. Maybe you have heard about it. It's a library of motion capture examples that you can import right into your scene. So you don't have to store them first somewhere. You can just go into the library and say, I want to pick this one here, load it in, and it's right in your scene. And I would like to show you that in the next example. So that's this one here. I'm loading in the background. Here we go. Okay, so I'm loading in the background a scene that that I've used in the past to explain the quick rig, the Maya quick rig functionality. So it is a character that has a rig in it with full body when I turn it on, human arcade full body mode. So this human arcade functionality allows you to move animation back and forth between characters. And that is necessary to, damn it, it has signed me out. Just a second. So you have to create your own account initially, and then that's my email, by the way. I hope that was the password. No, it's not the password. Otherwise, we would have to watch a film. Yeah, doesn't respect my password here. No, it doesn't do it. So we have to watch the film again. So I've been too long out of the account. After a week or so, it asked you to re-log in. And last week, I've been on holiday. So the motion library, as you can see it here, is this browser window. So it shows, or you can open the window here from the Windows pull-down menu. It's down below here, the motion library setting. And it lets you, hover over these tiles here. And then when you are on it with your mouse, you will see the animation that this does. So it's looped. You can turn it around. Just a second, let me scroll on. It's looped. You can rotate the scene and watch the. Let me see if I can stop this video by tapping. I'm afraid not. So I have to carefully watch where I click. So you can tumble this camera here and watch the animation from all angles. And then you see, and that's where many people get upset and very frustrated, you see there's a price tag on all of these. So this one costs you $6, this one costs you $3, and here's a $3, and so on. The good news is you can filter them by price, and then you get around 100 free samples. So the first 10 pages there are totally free, and you can download them. So here's one, for example, from a certain vendor, take one, an XYZ design. They offer examples for free that you can download without paying and playing around with it. Okay, so how does it work? I filter the whole thing by price. So let's have a look here at the walking stuff. And so there are publishers. You can filter by categories or by publishers. And also, let's see. So here I have filtered the whole thing by price. Here we see it. So here's the price filtering. And then all of the examples are 000. So the first 10 pages cost you nothing. That is 90, or I think there are 100 examples that are totally free. And then you can play around. And this icon here means I've downloaded that already, this particular motion. So there's a basket here or shopping cart where you can download an animation and then you check out and have to pay for it with your credit card. And, to load such a thing, or here's the shopping cart, to load such a thing, that's super easy. You click on this thing here. You can right click for the settings also, and then it will load that scene into your Maya scene. So here in the outliner, you see there's a new reference thing that comes up, and that's this extra skeleton that we now see here that's in my scene. And when I play this here, you see that now I have this character in my scene. So it's now, this is loaded as 120 frames per second. There are several ways. You can simply turn down the frames per second. You don't even have to scale the whole animation. Here in this example, I'm scaling it with a time editor. It's not necessary to do that. You simply shorten the timeline and then it will recalculate the whole thing. You see it already here. It does it in the time editor also. So there's no need to go into the time editor to sample it down. I just wanted to have it in the scene with these less frames. So now we have around 107 frames for the whole animation. Right? And what I do here, I clicked again, I'm sorry. So, and what I do then is to connect these two. You connected already? Here we go. So it's resampled. So up here, you can now tell this character, this quick character, hey, I want you to look at this new character in my scene. So it's called just character in this example here. And then suddenly your quick rig character or your own character, you can hook up your own rig, by the way, will move together with this character. This is an online connection. And to get the animation really over to your own character, you would have to bake it. So here I'm baking the animation to the control rig, to my quick rig character. Right? And when it's baked, you can really delete the reference altogether, and then you have your animation on your own character and in your scene. So now I can work on that. I can make my own stuff here on top of that. And I mean, look at what you get. You get a whole number of free samples, and also to get such an animation right, how much more money do you want to spend? It's only $3 or $6. It's so cheap. It's really not worth searching the internet for free animations. Just pick one of the motions out of here. You can full screen the whole thing. You get information about frames per second, duration, the whole thing. And you can sort by various tags. So that is a super cool improvement. I mean, it is something that's not for free. You still have to pay for it. But the fact that it is in Maya, directly in Maya, helps you a lot to save time instead of, you know, searching for yourself and trying to find something on the internet. Okay, so sorry for the last part here. I should have checked that demo again before the presentation here. I simply didn't realize that I get checked out of the Motion Library when I'm offline for too long. But I hope it came across and you could see what's it doing in your scene.